We have conducted a series of water talks before, and now this is season 2 of Water Talk, and I take pleasure to invite Dr. Pawan. Sir, we are so excited to listen to your talk, and the information that we got it in JJM training was really helpful for us. And to introduce today's speaker, Dr. Pawan.
Chaitanya, you're not audible.
Am I not audible? Okay.
No, you're audible to me at least, Chaitanya.
You are audible to me also. Yeah.
Okay. Am I audible now?
Yeah, it's better. Yeah, you are now.
Yeah.
So
we are starting the season 2 of the Water Talk. So I'm very happy to welcome Dr. Pawan, the first speaker of the season 2 Water Talk 2.0 at ICCW. So to introduce today's speaker, Dr. Pawan is currently the Professor of Practice in the Department of Civil Engineering at IIT Madras and former Chief Scientist at CSIR-NEERI. Holds a PhD in Environmental Engineering. With over 35 years of experience in water and sanitation, he has published 100 plus research papers, authored a book, and led WHO's Collaborating Center for Water and Sanitation. And he is a recipient of prestigious awards such as the IWA Project Innovation Award and the DST Lockheed Martin Innovation Growth Award. And Dr. Pawan chairs the BIS Committee on Point of Use Water Treatment Systems. He actively serves on several national and international technical committees, contributing to advancements in water treatment technologies and policies. So we welcome you, sir, and we are awaiting for your lecture. So I welcome you, please.
Yeah, thanks a lot. Mr. Nandakumar, Chaitanya, and other participants. So thanks for ICCW for inviting me. I have a presentation and I'll try to finish it in 4 by 4. So I request Chaitanya, so 10 minutes before 4, you please intervene. Otherwise, I may continue.
Sure.
So my slides are visible. Is it on PPT mode?
Yes. No, sir.
Okay.
Yeah, it's in the slideshow. Yeah, now it is.
Okay, great. So I'll be talking about beyond water quality monitoring, ensuring water safety with an on-field approach. And this is my important slide. And I start most of my presentation with this particular slide, which clearly indicates that I don't know whether septic tank was put first or this hand pump, which you see, was put first. But either of them is misplaced. And water which is drawn from this hand pump will no longer be safe. So what we mean is that in case if we implement some safety plan here, then we won't be locating this septic tank very close to the hand pump so as to get safe water from this particular source. So this was in residential school in Western Madhya Pradesh. So there'll be introduction in my presentation outline, and then I'll be talking about water quality safety status in rural India. Considering the fact that there might be mixed audience, so I tried to keep it mix of both scientific, technical, and which might be palatable to all classes of audience. So I'll be talking about water quality safety status in urban India, and I'll be briefly talking about water safety plan concepts and a pipe water supply study in which I was involved. I rather led this particular study. So I'll be sharing some of my experience related to water safety plan preparation for pipe water supply and at the end salient findings. So why do we need a water safety plan? And most of you who are really working on public health, they might be aware of this particular incidents which had happened in Walkerton, Ontario in Canada in way back in 2000. Not far off, and we obviously feel that the water supply in developed country is much safer, but you can see at the bottom of this slide, because of this particular incidents, 2,300 Canadians were sick, out of which 7 died, and they lost almost USD 155 million. And this had happened actually because the borewell through which they were supplying water, it got contaminated due to heavy spring rains, which the source was surrounded by fields, and then cow manure from these fields washed into the well. and there was no online monitoring, of course, and they failed to chlorinate, but that's fine. And unfortunately, operator and the chemist there fudged the data, and they reported that the residual level of free chlorine is almost 0.2, so that the water supply should have been safe, but it was otherwise. They didn't in fact chlorinate, and they supplied the water, and this particular contaminant E. coli O157S7 and Campylobacter jejuni, they were the responsible pathogens, and gastroenteritis were detected, and these were effect. So then it was realized that we should have something because of which we can prevent such instances. And water safety plan was first included in 2004 guideline of WHO. This is GDW, guideline for drinking water quality, in which this was highlighted. You might also be aware of this incident which had happened, I think, in 2023, where one student in Rajasthan Kota's coaching class died after consuming contaminated water. And when the investigation took place, they found out this particular coaching center was receiving water from tankers, and this tanker water was collecting water from a borewell. And when the investigation took place, they found out that there was a open sewer close to this borewell, and nobody actually bothered that they should properly treat, or they should avoid collecting water from this particular source. And this student unfortunately died, and 35 took ill. I'm sure that this incidents will also aspire and inspire us so as to go ahead with water safety plan. You might be aware of water quality, so I'll begin my presentation after highlighting importance of water safety plan by defining various water quality characteristics. I presume that most of you are aware of that. These parameters, the water quality parameters, can be divided into physical, chemical, and microbiological. And the physical consists of gases and solids. Solids can be further divided into floating, set level, colloidal, and dissolved. Chemical can be into organic and inorganic. And microbiological parameters, which are very important from health point of view, it's divided into pathogenic and non-pathogenic. And we can further divide these water quality parameters into different segments. So physical parameters can consist of like odor, color, temperature, turbidity, pH, etc. Whereas the demand parameters include dissolved oxygen, biochemical demand, chemical oxygen demand. And the microbial parameters, E. coli, fecal coliform, these are indicator bacteria to find out if the water is contaminated through any fecal matter. And then it can be divided into pathogenic bacteria, protozoa, and viruses. And similarly, we have like metals, aluminum, arsenic, cobalt, etc. Toxic compounds like polyaromatic hydrocarbons, polychloride biphenyls, pesticides, etc. So there are many water parameters which are now emerging. We talk about PFAS and other parameters for which we in India don't have any standard, but they are also gaining importance over the years. So we have like standards and guidelines, so as to keep all these parameters within some standards. So the most important most important standard is this IS 105 500-2012 Indian Standard for Drinking Water Specification. It, I think, provides standards, specifications for almost 70 odd parameters, and all the parameters which I listed except demand parameters, we included standards for those parameters. In addition, this standard is very important, which provide methods of sampling and tests for water and wastewater. In addition, Central Pollution Control Board in Ministry of Environment, Forest and Climate Change also have provided some standards. This is water quality criteria surface for surface water, and if you see, this is Class C. This is stipulated by Central Pollution Control Board, and this is used to classify surface water bodies for various designated best use, and two of them actually persist to two of them are for surface water sources for drinking water supply, and designated drinking water source without conventional treatment but after disinfection. So if that particular source meet these criteria, then we don't want to say impart extensive treatment, but only by disinfection we can meet the standard. And that's what actually it means. Another criteria C, drinking water source after conventional treatment and disinfection. So they've also given this criteria, which include total coliform, and it should be less than 5,000. pH should be between 6 and 9. Dissolved oxygen should always be more than 4 mg per liter, and biochemical demand should be less than 3 mg per liter. If these criteria meet, we can simply use this as the drink water source and treat it by using this conventional treatment, which include aeration, coagulation, flocculation, sedimentation, filtration, and disinfection. Most of the urban local bodies use these criteria to identify safe water sources to supply to community. Okay, I'll now come to water quality safety status in rural India. What is happening in India? If there are some international participants, I'm sure that the condition in their countries also will be more or less same if they're from developing country. So this water quality monitoring and surveillance framework, which was brought out by Ministry of Jal Shakti through Department of Drinking Water and Sanitation in 2021, it's an excellent document which clearly gives the idea that how the water quality monitoring should be done, what should be the status of district water laboratory, what sort of equipment will be required, what's the manpower requirement. So I suggest those who are interested to work on rural drinking water quality monitoring and surveillance should refer to this. Before that, I was involved in preparation of something known as a Uniform Drinking Water Quality Monitoring Protocol in 2013, and Ministry has released, and that actually had brought out a series of changes as far as the water quality monitoring and surveillance in rural India was concerned. And many laboratories were established, and now I think more than 2,000 water quality laboratories which are NABL accredited. So we have come, I think we have really come ahead as far as the water quality monitoring in rural area is concerned. So as per this framework, these 16 parameters, which we can call as rudimentary parameters, to be analyzed in district laboratories. So all the states have established state laboratories in which we can monitor all the 70 parameters, except I think some radiological parameters. And whereas these district laboratories are being set up in each district of India, and it has been made mandatory to say analyze these 16 parameters for all the drinking water sources. So I will show you a glimpse of this water quality data, how it looks, which is compiled by Ministry of Jal Shakti. So if you go to this IMS, information management, like integrated management information system, you get the data of all the states in this particular format, and then you can click on any of the states, Andaman Nicobar, Andhra Pradesh, and suppose if you want to know the data of Tamil Nadu, are you able to see it?
Yes, sir.
Okay,
yes,
great.
yes.
So Tamil Nadu, they have given the data for all the districts. So this is for this financial year. And see, Ariulur have tested, they have, I think, tested 6,300, out of which 35 had chemical contaminants. And there were bacterial contamination in 88 sources. So this is really excellent. So in Tamil Nadu, if you see that they have tested almost 6,61,000 sources. Oh, sorry, they have like 6,61,000, out of which 5,72 have been tested. So this is an excellent demonstration of the fact that we are really working very hard and not only collecting water quality data, but even disseminating the data. So in India, if you see, they have analyzed how much out of 1 crore 60 lakh sources, they have already analyzed 1,11,000 sources. So out of which we found that 23,000 number of sources with contaminant above the permissible, so 23 lakh sources are having chemical contaminants, whereas 13 lakh sources have microbiological contaminants. So if you look at the data, we are analyzing the data and then determining that how many sources have chemical and microbiological contaminants. But how should we go beyond it is the major concern. And there comes the role of water safety plan. So, Chaitanya, is it
Yes, sir.
visible?
Yes, yes.
Great.
Yes, it
So
is.
I'll give just one small example how actually the state disseminates their data, and this is from West Bengal. And this is for field test kit. And then if you see that they distribute this field test kit through ASHA worker, and they collect samples and analyze them. And this data is supplied to the block office, and the report is collected and supplied to district PhD officials, and they're fed into their say state IMS, information management system, and in turn they also submit it to this government of India IMS, which I just shown. But the best part of it that water quality test report shared by email for remedial action, and they see most of the panchayats are now connected through email, or they have like some system through which they can send even SMS also. And they insist that wherever they found say high bacteriological contamination, then it should be chlorinated. If they found some chemical contamination, they should be appropriately treated, or the source should be discarded, and we should look for some alternate safe source. So a lot of work is being done in India also as well as the water quality monitoring surveillance. So we are now extending and utilizing the data, water quality data we are collecting throughout India, and then try to ensure that we either have preventive measures in place or have some treatment options so the community is served with safe water. And this is also from West Bengal. And if you see in it that they have given this type of matrix to all the districts. And then they have given, say, they have recommended also, say, before total irons more than 1 mg per liter, which is BIS 1050/2020 standards, if the other thing for the source is in hand pump. And then the community to be informed and diverted to nearby tested and safe water sources till they install any alternate water treatments plant. And they also, if the free residual chlorine is between 0 to 0.2 mg per liter, then they also recommend that the chlorine dosing should be increased by PhD. So they are coming out with their own options and solution. And this, in fact, is a water safety plan where we are utilizing water quality data being collected at, say, 1 crore sources. And then our aim is not to analyze water sample only, but ensure that some treatment or preventive measures are implemented so that community have access to safe water source. So this is really good. And they've also given that what should be done if bacteriological water, say, if H2O are positive, then community to be informed and diverted to a nearby source, and say, Gram Badan alerted to facilitate disinfection of the hand pump to well. By Gram Panchayat or VWSC, Village Water and Sanitation Committee. So these measures are in place. I then knowing that we are doing it, say, very thoroughly, but of course the system is in place. We are progressing towards achieving safe water supply to rural India. Okay. So now coming to urban area. So this in March 2024, Central Public Health and Environmental Engineering Organization under Ministry of Housing and Urban Affairs released a water supply and treatment manual. And there are 2 chapters in 2 volumes, and which highlight that how the water quality monitoring and surveillance should be done. And they, in fact, this document, in fact, has approach to water quality surveillance, water sampling, methodology, sampling, location and frequency, establishing monitoring and surveillance mechanism, planning and implementation, reporting water quality data to community, as I given an example to you for rural areas. Similarly, they also suggested that we should intimate the water quality data to community, and database management, record keeping, water quality management system in urban areas not as robust as the rural India, because data in urban towns are not aggregated. So we are like disaggregated data in urban area, and we have proposed to this manual that we should have a similar system in urban areas, so that if somebody wants to access data at a glance, he or she should be able to access. And as I told you, they have given where the water sampling should be done. We should do it at the intake or tube well. We should also do at the inlet and outlet of the treatment plant, at the inlet and outlet of elevated surface reservoir. There's something known as the district meter areas, which are hydraulically, say, isolated independent areas. And at the same time, we should also monitor at the critical point in each DMAs, district media area, and at district location in the network. So these are local assembly indications we already included in our manual. And see, as far as the distribution system is concerned, parameters are very limited, like turbidity, conductivity, pH, E. coli, thermotolerant coliforms, total coliform, pre-residual chlorine. So for source, we have recommended that we have to analyze all the 70 odd parameters, whereas in distribution system, once established the source or fee of contaminants, and then we are providing ample treatment to it in distribution system, we have to monitor only these 6 parameters. And it has been recommended in this particular manual that water safety plan should be prepared for each utility. And I'm sure that during the course of next 5 years, most of these utilities will definitely have water safety plan prepared for them. So I'll just now move over to another. Yeah. So this is all about water quality. We have really progressed very well in the last 10 years or so. And our laboratories are annually accredited. We can monitor water parameters we need to monitor. And now we have to ensure that how to utilize water quality data which we have generated over the years, and we are generating for all the sources. And there's no fun in, say, collecting data, water quality data, unless we ensure that we have preventive or curative steps or measures in place, so that we ensure safe water supply to community. So what is water safety plan? Yeah, why do we need? Why and product testing compliance is not enough, though it's really good measure that we should say undertake water quality monitoring, but it has limited utility. It's a reactive, yeah. It is not an anticipatory mechanism to do water quality monitoring, because a problem has already occurred. I have given 2 examples of Kota and Walkerton. It's more to do with reactive as far as the water quality monitoring is concerned. As those who are involved in water quality monitoring surveillance, sampling takes time, and that's why the response for corrective measure is also delayed. So you see this particular schematic, you will say if the water becomes contaminated here, we test water even after the contamination, before we actually submit the results, which sometimes can take say 24 hours, 7 turn around time recommended by rural for rural water supplies. I think 2 days or 3 days, but take sometimes even more time. But by the time we get test result and then come to know that the water is already contaminated, the consumers have already consumed water. So what's the use of this test result? Yeah, of course, it is certain utility. Yeah, but at the same time, we should have some other tool through which we can ensure before we consume this water, which is contaminated, the bases are activated, and the community gets safe water supply. So this end product testing is still important for verification. So we should not discontinue monitoring water quality. We should definitely continue, but we can use it for say end product testing. This water safety plan is not new, and it is not only restricted to developed countries. It has been already implemented in 93 countries. I think as on today, it should have been implemented in more than 100 countries also. So we are not doing something which is rocket science. We have been doing it. We can easily do it. Only thing is that we should have some motivation to do it. So most of you work in this particular say segment. You might be aware that what are the different elements of water supply system. We have a catchment. I'm specifically catchment, a watershed. When we are exploiting or using groundwater, then we call it as like watershed. Whereas when we're using it for surface water sources, it's known as a catchment area. So the water flows to this catchment area. It comes to source, and this can be a reservoir. From there, the water is sent to treatment plant, and after treatment, it's stored in storage, and normally through gravity we distribute it to households. And this is a typical water supply system we use globally, not only in India. So what is water safety plan? It's a comprehensive risk assessment and risk management approach that includes all steps in the water supply from catchment to consumer. So we have to manage water quality risks here to provide safe water. So risks are the event which can contaminate your water. And these events can be anything. And I'll discuss in detail as we go through the presentation, what are these risks or hazards to entire water supply chain, because of which the water can get contaminated. So what we have to do in water supply safety plan, we have to identify these risks. What are the risks to water supply chain, right from catchment to consumer? How should we control these risks? And later on, how should we monitor effectiveness of this control? So this is in nutshell what safety plan is. There are various steps in water safety plan preparation, and people feel that it's slightly cumbersome, but I don't think so, because I was involved in water safety plan preparation since 2005. So I know that it's not very difficult, because as I told you, WHO introduced this in 2004. So we have to do something known as a water supply system mapping. We should know our system. See, if you ask anyone, and say I'm from Nagpur, even in Chennai also, from where you get the water, and the normal response to it is that we get it from tap. But see, it's a complex network system, and we need to know how the system works, water supply system works. Then we carry out a risk assessment. We introduce some control measures. And if these control measures are not enough and the risk still exists, then we have to go for improvement. And to know the effectiveness of these improvements, we have to do something known as monitoring and verification. And that's how it's a cyclic process through which we ensure that these risks are eliminated and are minimized, at least, so that we get safe water. So this is WHO manual. I think it was published in 2012. So I'm going to tell you about a case study which we did in 2013, 2014 here in Nagpur. So it was like 11 steps, 11 modules through which this water safety plan is to be prepared. First is assemble the water safety plan team, and then we have to describe the system, describe the water supply system, identify the hazards event, and assess the risk, and then determine and validate control measures, develop, implement, maintain an improvement plan. Then we have like operation monitoring, we have to have management and communication, and feedback and improvement. That's how WSP is prepared. So I'll skip a few of the steps here, but I'll explain some important steps of water safety plan. So now I'll come to this particular, say, water safety plan which we prepared for Nagpur water supply system in 2013, 2014. And we continue to do, I think, for say next 5 years. So 2019, I think, till COVID, we continue to improve this water safety plan. So this is in Nagpur. Nagpur is here located in Maharashtra. And it has area of 217 square kilometer in 2011. The population was 2.5 million. And the water supply is controlled by Nagpur Municipal Corporation. As in Chennai, it's controlled by Quad Board. We had 80% of coverage. It means that 80% of the households in Nagpur were receiving water supply. There were like 225,000 household connections, water supply connections. We were using a lot of water, 650 million liter per day of water. And I think 500, 650. Now its population is increased to almost 30 lakhs. But we have restricted our water consumption to almost 700 mld by reducing, say, something known as a non-revenue water. So now, that time when we did study, 50% non-revenue water, and 60% of population was receiving less than 135 liter per capita per day of water, which is recommended norm by CPHU, and 4 to 24 hours supply. So Nagpur was first city where we introduced 24 by 7 in a pilot area, which had like 15,000 households. We ensured that all households in this particular pilot area receive water 24 hours, but rest of the part of the city was receiving water only for 4 hours. So this is schematic of Nagpur. I'll take some time, and then please bear with me. So we have like a river, Panch River, and then there was a dam we constructed, and there's a pickup weir we call as Panch Carry Dam, and so from where we take about water by 23 pipeline, and we had constructed one bench 4 water treatment plant. We have this pumping station. We have this like three water treatment plant. They're very small, like bench 1, bench 2, bench 3, and they supply water to 3 master balancing reservoir and to network of elevated surface reservoir. And this, I think, supplies almost 400 mld of water to Nagpur, whereas this river, Kanhan River, supplies almost 200 to 225 million liter per day water. And then we have constructed a water treatment plant here, and this supplies water to Nagpur, or to eastern part of Nagpur. So this is a bird's eye view of Nagpur water supply system. Yeah, when we started working on this in 2011-12, the water supply system was slightly different. So we like to do them, and this Panch Carry pickup reservoir, from where we had like this right bank canal, and from there we were using this Mahadula pumping station, sorry, and from there we were actually, yeah, supplying it to an intermediate lake. So what we were doing actually, from Totlado Dam, we were transferring water all the way from Gorewada Lake. So this was our intermediate reservoir, and from Gorewada Lake we had this network of Panch 1 water treatment. We had like 3 treatment plants here. So this was a schematic around 2010 or so. So and yeah, this break pressure tank is required. You know that otherwise all our appurtenances will get damaged, because the pressure which comes through this particular pipeline is very, very high. So that's why we take BPT. This was our network in 2010, and it continued. We had some improvement in between, but this was basically when we started preparing water safety plan. And this is the water supply system. As I told you, we had like, of course, Kanhan River. I didn't show Kanhan River there. So we had like Kanhan treatment plant, and then we had like this like Panch 1, Panch 2, and Panch 3 treatment plant when we started. Now we have like Panch 4 also, and there were like small Gorewala treatment plant. This was at the beginning of water safety plan around 2013, and then we were supplying this water, pumping this water to 2 master balancing reservoir having capacity of 25 lakh liter, and then there was another governor house MBR, and through network of 60 elevated service reservoirs, we're providing it to, say, consumers. So, and this is how we prepare water supply system for all the cities. So if you go to any city, say for Chennai or Kolkata, you'll find similar system there also. Only addition might be in some cities they use groundwater, whereas we were using, or we still use, surface water sources for our water requirement. So as I told you, we have to identify these hazardous events or risk. Means the events which can contaminate water. So you know that rainwater is not contaminated at all, but as it flows through catchment, or if it flows through ground, say below ground, then it gets contaminated. So that and these contamination occurs because something known as a hazards or risk. So we identify all the possible hazards in Nagpur supply system. Say we'll start from watershed, and And you know that I talked about this Gorewala Lake, and this Forest Department of Government Maharashtra was planning a zoo in 2011-12. Obviously, you can see that this is the catchment of Gorewala Lake, and if you put something inside it, and they were planning some restaurant, they were planning some offices there, and without any proper treatment, this Gorewala Lake would have been completely contaminated. And you know that we're putting 400 mld of water in this particular lake. And what had happened, we actually approached Gorewala Zoo Authority or Forest Department to locate all the infrastructure outside the catchment. And we also suggested them that they should install some treatment plant also. So fortunately, they heard us, and now this zoo is located out of catchment. Moreover, over the years, we are not now pumping water to Gorewala Lake, but directly pumping it to 3 water treatment plants. So that improvement we actually did based on the water safety plan. So this was a major hazard. If you could have not appropriately handled it, it might have contaminated entire Gorewala Lake, which was storing 400 mld of water, which in turn was supplied to citizens of Nagpur. Come to source here. This is a classic example where engineering fails, I feel. And I told you one of the source for us is Kanhan River. And this is Kanhan River. And this is the intake well through which we get water. And this was established way back in, I think, 1950s and 1955. And in 1985, they constructed a thermal power plant. And just upstream of it, they constructed this ash pond. This is very foolish in part of thermal power plant authority to construct this ash pond just upstream of intake well. And what we actually found in while preparing this, there was a breach in this particular ash pond. An entire water, not entire water, but the part of the water from this ash pond, which is highly contaminated, it had like 7.6 mg of liter per of fluoride. It also had metals like arsenic in it. It breached, and through this, it actually got it contaminated our intake well. And this was the situation in our intake well. Otherwise, the water is blue, water is colorless, I mean. But after the breach in this particular ash pond, this our intake well got contaminated. We had to, I think, close down this intake well for 3 days to repair it. And this is how we identify the hazards, possible hazards. And if we could have done water safety plan way back in 1980s, then we might have not located this ash pond here. We might have located it somewhere else, so that even if there is a breach, it would have not contaminated our source. So this is water safety plan actually talks about preventive measures. So we had to close down this. So this clearly gives idea about what the hazardous event risk is, and then how should we actually deal this risk hazards in preparation of water safety plan. We should try to minimize these risks as much as possible. Coming to treatment. So this is how we were doing aluminum chloride dosing in our Gorewala treatment plant. Now we have discontinued using Gorewala treatment plant. It was British era treatment plant supplying treating only 16 mld of water. So we discontinued it, and otherwise this is unregulated free. But if you go to any small town treatment unit, the PAC dosing is done this way. Which is absolutely wrong. So this is not effective way of coagulating water, and this imparts risk to water supply, because if you are not properly doing coagulation, it means the colloidal particles will go through, and then the purpose of say removing colloidal particles is lost. Similarly, this you can see the aquatic weight and clarifier. So this is how the aquatic weight. But I think if you go to some of the treatment plants now also, I won't get surprised if you don't see the similar scenario over there. So what I mean is that we have to really see that how best our treatment plants are maintained, and this how it was. Fortunately, this treatment plant got discontinued. Coming to storage, yeah, this is inlet to our master balancing rod. This particular wall, if you see, this is leaking. What happens if during non-supply hours, the water which got accumulated here gets sucked into the MBR, and MBR, master balancing reservoir, stores treated water. And because of this back suction, the entire water supply gets contaminated. So this we identify as one of the major hazard when we did water supply plan. And these are the real photographs from the field where leakages occur like this, crossing of sewer lines and dig over the pipeline. This is how the pipeline is laid. It's exposed to a drain and the corrosion of pipe. So the weakest link in entire water supply system is the distribution system. So we have to be very cautious about it, and we had identified several such hazards or risks which were possibly contaminating our water. So I think, yeah. So actually, this is slightly technical, so I'll try to rush through as much as possible. So we use something known as a risk assessment tool. So this is IRAWDS, means Independent Risk Assessment Water Distribution System tool, in which the entire distribution systems map we collected, and then we try to identify the weakest pipe in entire distribution system which might be contributing to contamination. So we collected data from Nagpur Municipal Corporation, and we also did field survey, and the consultancy which generated these GIS maps. Fortunately, most of the urban towns have GIS maps. So this is how it looks, IRAWDS. So it has three modules: a pipe condition assessment model, contaminant ingress model, and risk assessment model. And we collected data to run these three particular models. And this credit goes to my colleague, Dr. Abha, who really coordinated entire work. So it actually gives that determine how contamination may arise, take measure to prevent contamination, and then improve quantity management, improve water quality management. So what we actually did in this is water supply network. Similarly, we also collected maps of sewer and drain. We overlaid these maps. And then in addition, we collected some attribute data such as installation year, diameter, material, length, location of wall, buried depth, manhole number, ground elevation, everything we collected. And we also analyze data on pipe breakages. We collected this data from Nagpur Municipal Corporation, how many number of breaks in pipes, and in addition to in which year this pipe was installed, how much the traffic load if it's laid on the laid below the road, how many bursts have actually breaks and bursts. Bursts means where the water actually comes out in jet form, whereas breaks is where water leaks. So we collected pipe material. So this is an example. Pipe material, we only cast iron installation in 1980, traffic busy, medium, and then like 50 centimeter, 100 centimeter diameter. How many breakages were there? So we had like 5 breakage. So number of breaks were 107 and number of bursts were 81. So these data we collected. And by running that model, we could identify where actually the very high risk and high risk pipes exist. And then you can see these are the one here, one. These are the high risk, very high risk point, as to indicate. So this gave an idea to Nagpur Municipal Corporation. They have to first replace the very high risk pipes. And not only it contaminates water, this also leads to a lot of water losses as well. So this mapping exercise, this modeling exercise helped us to identify the weakest links in entire distribution system. And this had also helped Nagpur Municipal Corporation to prioritize pipe replacement. And I think if you zoom it up, we had gone to the detail of what's the pipe IDs. We're given different pipe ID also to them. So this is an extensive work which we actually done, and then we're given at what risk level this pipe lies. So yeah, different legends we have used. We in addition also did pressure and leakage monitoring also. So one thing is that we get some result out of the model, but most of the time these results are not verified in the field, and we end up getting some wrong results. But what we actually did is we did field verification at critical locations. We did extensive water quality testing for various physico-chemical nagar in this locality of Reshimbagh and Manzari Nagar. And we monitor water quality at elevated service reservoir at critical location distribution system, where we had identified high risk and very high risk and high risk pipes, and we did water quality monitoring at consumer end also. And this was the situation. Say, if you go to any city, you'll normally encounter such scenario. You can see the water is the pipeline is laid like this. They have to sometimes install these pumps to fetch water from pipe, like distribution pipe, or water is like collected at the bottom because it hardly had pressure. And then we could verify wherever there were high risk point, we had very low residual chlorine. At the same time, we had very high total coliform, fecal coliform, and fecal streptococci. So it proved that water findings we got from model were actually true. And then that had been verified by extensive field data also. So we were happy that we spent so much of time in conducting this, collecting data, conducting modeling studies, and then it really helped us in getting good results. Okay, now at the same time, what happens? We also found out that there exists a lot of hazards or risks at household level, and this is a classical example, and this is true for all this. So this has been collected in Nagpur in 2013 as part of WSP, and if you see that at source, we have like those who are aware of microbiological terminology, we found almost 85 CFU per 100 ml of fecal coliform, and it was fairly low at WPP raw water. After we treat water, we chlorinate, it will be obviously zero. We didn't find any, say, fecal coliform at master balancing reservoir, but as it's the water is transported elevator surface, we got contamination at stand pores and taps also. We identified or we got some contamination, but they were fairly low. But when we collected water samples from households, a point of views, we found out that the water gets contaminated to the level which we found at the source. This also clearly indicates that we don't normally handle our water appropriately. At the same time, whatever investment we are doing in treating water here, that gets wasted because we recontaminate water at household level. And we try to find out what are the possible say risks which contribute to water contamination at household level. So we conducted this extensive sanitary survey also, and that these were the major risks which contribute to water contamination. Is storage designed for dipping? Do they use dipper with short or no handle? Is the weather accessible for children? So these were the major risks. And you can of course provide some residual chlorine to it, but at the same time, unless we carry out awareness among the citizens, I think we'll badly treat our water and it gets recontaminated. So awareness building also is a major part of entire water supply system. Oh, sorry, it's water safety plan. So we identify 109 hazards. Catchment it was like 28. We could address only 7. In treatment plant 42. We could address only 48. 28. Sorry. In storage 13. We could address 8. Consumer rate we don't know because it varies from consumer to consumer. Distribution we could address most of them. 16 out of 16 we could address 13. So hazards, I think that's really good. We can't address all 109 because they even include smaller ones. And then we have to do something known as semi-quantitative risk assessment. I'm not going to say details of it because that's another lecture. So this type of matrix needs to be carried out where we determine severity and likelihood. And this likelihood varies from 1 to 5, and then severity also from insignificant 1 to 5. And this red indicates this is highly risky proposition. And this is how we use this particular system to map. So we mapped entire water supply system of Nagpur and determined this risk matrix for even smaller hazardous event for 109, which I just shown to you.
Sir, just a reminder, it's 5 to 4.
Yeah, I'll wind it up now.
Yeah,
okay.
Thank you.
5 minutes. Yeah. So what we actually told, so this is how we implemented zoo-related infrastructure. I told you outside the catchment. we have built a communication between this power plant authorities and Nagpur Municipal Corporation, so that if the breach occurs, we strengthen even band around this ash band also. And treatment, hazardous event, no coagulant dose. We suggested hot. So this is how we suggested strengthening control and preventive measures. So you can see you already seen the leaking wall. So instead of that, this wall was changed to butterfly wall, and and then it was not leaking at all when we inspected it. And I think this was the scenario before this scenario. So we completely eliminated these pipelines and provided this type of appurtenances on pipeline. So performance indicators are also improved before WSP coverage was 80%, it reached 90%. And if you say there's a consumer, this also is increased. And extent of non-negative water also came down from 60% to 50%. And water quality also improved a lot. So this is the improved system in which we completely replaced this canal, and then it was replaced by I think MS pipes. So this is how it looks now. We eliminated that canal through which we were supplying water supply earlier. So we did, I think, periodic survey of this, and I also identified additional 13 hazards in 2017. So I'm just coming to close to my talk, and then what are the initiatives which have been taken in rural areas? And then this Indian Foundation has initiated this Jal Exchange campaign for empowering water quality champions, and it's designed to support certified water quality champions. So they're creating a network of these water quality champions. So they not only collect water quality data, but ensure that the water quality data is used to secure water safe communities. And our water safe community ensures safe and secure water across basic life needs, productive needs, and ecosystem needs. So working, I think, in few of the states like Assam, Gujarat, etc., Rajasthan, they work. So, and they have created this conversational WhatsApp board called Our Water and Water Data. And they also encourage photo evidence, collection of photo evidence and local testimony. And they also had like fortnightly problem solving sessions. And they also have like regional meet. So this is really good. And I request you and suggest you to go through this particular initiative of Indian Foundation. They have used this Glyphic Jugalbandi Bhashani in their bot. And you can access this water bot through this particular link. And this is very interesting. If you become part of this particular system, then you get all the details. Means if you feed some data, some problem to it, the AI generates and it's verified. They have like a bank of solutions for all the water quality problems, and based on the problem, one user or this champion narrates, the solution is provided through WhatsApp. So this is really good initiative in which we are utilizing water quality data being collected through water champions, and solutions are provided through this particular Jal Exchange campaign of Indian Foundation. So so this is salient finding. I told Chaitanya I'll close it at 4, so it's 4. So salient findings of my presentation is water supply plan is extensively used globally. Water quality monitoring institutional mechanism is being standard in rural and urban India, and I have really given good evidence of this through my presentation. I think water safety plan being implemented in subtle way in India. There are some case studies available, but unless we institutionalize it, I think it won't happen. Fortunately, CPHO has come out with manual, and I think it will become mandatory for these water utilities or urban local bodies to prepare water safety plan. You're seeing the benefit of preparing and implementing water safety plan. As I told you, there are isolated examples. There are really good examples from which we can really learn how to implement water safety plan. And as I told you, water safety plan will definitely receive impetus through CPH manual, and in CIP framework also suggests that in rural area also we should try to implement water safety plan, and this gel exchange from Indian Foundation is a step towards achieving safe water for the community. So this is the second edition of water safety plan manual. So my name is also there, so I contributed a bit to it. And this is water safety in distribution system. This was also borrowed by World Health Organization. So I was one of the author in it. And of course, this is the Bible of guideline for drinking water quality. So I also contributed in this particular document. At the end, I would like to acknowledge ICCW for giving me this opportunity to present something which I did myself. IT Madras, of course, where I am working as a professor of practice, like Professor Dichi and others helped me to be there. CSIR-NEERI, through which I did this particular work. WHO CRO office, which supported this particular work. Central Public Health Environment Energy Organization. I would like to thank them. Jal Jeevan Mission, Nagpur Municipal Corporation, Indian Foundation, and last not but the least, participants. Thanks a lot. Over to you, Chaitanya.
Thank you, sir. Thank you so much. Such a wonderful session, and I have a lot of questions I thought I would discuss with you.
Okay.
Before I start, I would invite the participants if they have any questions or any doubts. Probably they would unmute and ask here.
Sir, namaste, sir. I am Chandrasekharan from Watson in Envirotech. I do water purifier for the rural folk using the CSIR terrafill technology from Bhubaneswar.
Can you be slightly loud? I am unable to hear you.
Sir, yeah, I am doing a natural water purifier to be focusing for the rural folks only, a standalone filter. And I also adopted Dr. Pradeep's arsenic removal technology. We are also doing fluoride removal technology. I wanted to ask you one simple question. What is the largest contaminant which is still yet to be solved in the last mile in the rural areas? Which do you think is a contaminant which is really a challenge for us to solve in a bigger way?
Yeah, I think very good question, and I compliment you for doing this great work in rural area, Lies. And I feel that I couldn't present, but if you see the disease burden due to contaminants, microorganisms or pathogen offer, say, huge load of disease burden. Of course, we should focus on chemical contaminants, but I request you to also concentrate on microbiological contaminant pathogens.
Yeah, by
And for
default,
that,
sir, by default, the microbes are removed. Otherwise, it is not called as a water purifier. But the challenge
yeah,
lies is the data what the government gives, and in real time when we go and do the testing, these are totally different. Okay, so that is the biggest challenge what we are facing. Second thing, sir, I wanted to ask you: is TDS really a problem for drinking water? Because as per what I understood, before 2012 ratification in IS 10,500, the permissible and acceptable limits were 200 and 500. Okay. Later, when the Supreme Court and the Green Tribunal came across the RO companies, we were wasting water, we were using a lot of energy and reducing the TDS so low, like 50 and 60. Then there was a ratification that the permissible and acceptable limits became 500 and 2,000. Straight away, it became 4x. So, what is really the TDS issue? Is TDS a major problem to be solved? Or is TDS really not a problem? We need to have a get clarification on this.
yeah. See, you should allow me to speak. Okay, first, let me complete the first part. Yeah, of course, it removes, but unfortunately, what happens? I've shown you one example. Even if we treat water, but we poorly handle our water. Even if you point to use water treatment system, we still get it. So we should have something which provides us residual benefit also. So the chlorine, I think, might be a good option. Secondly, coming to this tedious business, I was a member of the committee which actually drafted this report and submitted to NGT. So it's not correct that this based on the NGT and Supreme Court order, the TDS levels have been increased 2012, because it was issued in 2012 itself, and this case was in 2017 and 18. So yeah, coming back to this, what happens? Yeah, we have like acceptable limit of 500 mg per liter and permissible up to 2000 mg per liter. But yeah, we have seen, I think you might also seen, we worked extensively in states like Rajasthan, where people normally have water with very high TDS in the range of 2000, and they normally reject such water. So in such cases, of course, there's no option but to go for RO. But it doesn't mean that wherever we like very safe water, where we can by other means, by say UV, we can remove these pathogens, we can't use it. So RO is not panacea for all water treatment. We should restrict TDS. Of course, see, there's a lot of work which had been done. There's some studies which clearly indicate that if we don't have any TDS in water, we like limited TDS in our water, maybe 15 or 20, it's not very harmful to the health. We can get these supplements from food. But there are a lot of studies which also indicate that we should maintain a minimum calcium, magnesium, and TDS level in the water. So my take on it is that, okay, RO is not a universal treatment. You should limit it, and we should maintain at least minimum 50 mg per liter of Ca and around 30 mg per liter of or 80 mg, 50 to 80 mg per liter of calcium, and say 30 to 50 mg per liter of magnesium in water, and TDS maybe 100 or 150. Okay, minimum. But see, taking TDS 500. 500 also is not harmful unless all other chemical parameters are within the standard. But the claim, I think we can debate on it extensively. So I had debated with all these manufacturers. So I had my own point of view about it. But they collected a lot of data and went to the Supreme Court. And Supreme Court then recommended that, okay, there should not be any restriction of 500 mg per liter of TDS. So the NGT recommended that wherever water supply has less than 500 mg per liter, in such towns, they should ban RO water. RO point of use water treatment unit. But these manufacturers had gone to Supreme Court and pleaded that, okay, that's not correct, because some of these households don't have water supplied from municipal corporation, so you should allow whomsoever wants to use it. And Supreme Court then agreed with their request, and then they turned down NGT's order and recommended that, okay, there should not be any restriction in sale of these RO-based point of use water treatment system.
Yeah, excellent answer, sir. In fact, the problem lies with this cartelization. What is happening in the government tenders? Our type of new innovations and technologies don't even have a say, and only RO is being referred. That is why, what sadly, as you said, RO is not needed everywhere, but it is used everywhere. That is the irony. Thank you, sir. Excellent answer. Thank you, sir.
Sir, can I come in?
Yes, please, sir.
Please. Yeah. I see some contradiction of principles in NBC, which recommends hardness permissible, 300 ppm, but acceptable to 600 ppm. Now, chlorination effect is compromised above 150 ppm hardness. So, world over, chlorination has failed. Now, due to hardness, so much of chlorination is done that world over 70% of chlorination equipments are not functioning. Now, if we go to cryptosporidium, worm ova, giardiasis, and rotaviruses, they are resistant to chlorination. Now, under this kind of situation, how do we go about, or what do we call as safe drinking?
Yeah, you're very correct. Chlorination, like any other technology, has its limitation. We were discussing about RO. So RO also has limitation. Yeah, we were discussing about coagulation. That also has limitation. Yeah.
Sir, conflicting principles I am talking.
Yeah,
chlorination above 150, not effective. And our NBC says 300 to 600 per VC.
Sir, I would request you to share this paper in which they have mentioned that if this is more than 150 mg per liter, hardness more than one.
World
Sure.
over, initially, sorry, आप बोलिए.
See, if you see world over, except in Europe, but if you talk about Spain also, they're using chlorination. US also they use large, say so many utilities use, chlorination. Yes, still they use.
I'll share the history of fresh water
Yeah,
supply.
yeah.
You see, initially, Europe had 100 ppm chlorine, and USA, to show superiority, they had 60 ppm hardness allowed. 100 ppm hardness in Europe, 60 ppm in USA. Then there was water shortage, and everybody started drawing from tube well. So Europe raised it to 150, and USA raised it to 100 ppm hardness. But beyond that, they are unable to go or raise hardness because chlorine effectiveness is compromised, gone rather. It is as good as no chlorine.
Sir, I mean, I've not seen any literature. I request you to share. I might be negligent to it. See, what happens chlorine? Okay, I think we can discuss later because it will really good to learn from you that how would it happen. But see, but there are many options. So what we are doing is we are exploring something known as a nanobubble and ozonation. And this nanobubble is a nano-sized bubble, and it indicated that the life of this nanobubble will be very high in water, so that the ozone remains in water for longer time, whereas the half-life of ozone is much lower. So it can impart even the residual benefits. We are exploring even having that in India, but chlorination also has some benefit. It's not because
no, I'm not denying that.
I'm just putting my point of view. So you of course didn't tell that it doesn't have benefit. Of course has, but if we can use combination of that wherever we can, and as you pointed out, if there's some precursor. So you might have also heard about trihalomethanes. So like precursor organics, which can lead to formation of THM. Unfortunately, our water also has some precursor. But in India, there's no study done, or except 3 studies which had been done on THM formation. So, see, we have to do a lot of data collection studies and then come out with our own standard. We shouldn't rely on what is happening in Europe or US, because we are more resistant than them, I feel. Yeah. So even zero E. coli also I don't believe, because we were tolerating 10 E. coli. They come here, drink our water and feel sick, whereas we are drinking the same water for years together. So,
that is our built-in resistance factor of the community or population at large.
Yeah.
For example, there are certain published data where Klebsiella, as they say, will have the last laugh on this planet. When every life has gone, Klebsiella will survive. At a dead end, after 12 years of 1 ppm chlorine residual content, they found Klebsiella thriving. 12 years of 1 ppm chlorine residue.
yeah.
So engineering, they are losing their sleep and working very hard. But because of their background on the microbiological aspect, and microbiologists do not recognize water supply as their area, they take it up only when somebody is admitted in a hospital. So it goes to pathology.
Yeah.
So there are...
You're very correct. So, see, chlorine, when they like protozoa, they are highly resistant. And we really don't know that how much protozoa in our water, because monitoring protozoa is extremely, say, cumbersome. So these are some issues I think we really need to solve. Yeah, you know that monitoring the protozoa itself costs a lot. So
now they are no more protozoans. They are known as apicomplexa.
okay.
All giardiasis,
Giardia,
and all that. And giardiasis have affinity for acidic pH. In human stomach, the pH is 2. And they thrive there.
Yeah.
So, I mean,
fine, sir. I think we will definitely discuss. I request you to share your contact, and then I'll get in touch with you. Okay?
I'll certainly.
Thank you very much. Thanks. I think your insights are very, very important. Yeah, thank you.
Thank you.
Thank you. Thank you, sir. Any other questions? I think the participants are requested to share the presentation, sir. So
Yeah, I'll
probably
do
if you
that.
could, yeah.
Good afternoon. I missed part of a presentation, but I would just like to understand whether are you considering cancer happening due to water contamination as a part of monitoring studies?
Yeah, I think very good question. So, what happened? Epidemiology of cancer itself is very complex. So, there are several confounders. So, yeah, as we were discussing about chlorination, and you know that yeah, one of the outcome is one of the outcome of chlorination is formation of trihalomethane, and trihalomethane I think is one of the cause of particular type of cancer. I just forgot about it. And see, and how did they actually did it is they collected data of THM and correlated with the cancer, this particular type of cancer, and they found out this particular cancer is highly prevalent in Spain, and Spain uses chlorination, and that's how this THM might be causing cancer. Of course, there are some other studies, epi studies, which have been done, and which also correlate formation of THM to cancer. So my suggestion, my understanding as far as the cancer and water quality is there. Of course, arsenic, it's proven that because of arsenic it happens. There's some other metals because of which also cancer can occur. At least it gets exaggerated, and yeah, but sometimes I feel that there are other causative factors which are more responsible than say water contaminants.
Thank you, sir.
Can I add, sir?
Yeah.
As you rightly mentioned, excess chlorination can react with the epithelial cells of the endothelial cells of the gut, and of course the colon. And Europe has highest colon cancer percentage because of their meat eating habit. Now they have the fiber food is introduced in European and Western food recently. Otherwise, we were the fiber eating populations, not them. But then there is a new branch of medicine coming up known as mitochondrial medicine.
Okay.
Water treatment has nothing to do with cancer cause. Anyway, some other time we engage
Yeah,
on that.
we'll discuss. I'll surely like to discuss. Where are you based, sir?
But then I'm at Surat,
Okay.
based at Surat. But the point is, BOD is the most ill-conceived terminology with engineering. It's not biological oxygen demand. It is the demand for biological oxygens. Atmospheric O2 has nothing to do with BOD, and therefore entire DO concept and energy losses due to aeration. It's a pure overhead designed to render the society poorer without gain. We'll engage
Yeah,
deeper.
we'll discuss.
I think these are all some of the questions that I would like to discuss with you. Probably it will take some more time, but just to highlight, I wanted to understand the model that you have used for identifying the vulnerable zone points, you said. So we are also trying to do a similar study of that. I would like to know.
Yeah. See, this model is known as the IRA-WDS, Independent Risk Assessment Water Distribution System. And you might have seen that two or three components. One is pipe assessment,
Yes.
and there's some other model. Yeah, I think environmental assessment or something, in which we want to first know that condition of pipe,
Okay.
how old it is, what metal it's made of, how frequently it leaked.
Yeah.
And secondly, there's some attributes like environmental attributes like soil, yeah, and at how much depth it's laid, and how much the moisture contained. So that those attributes we combine with other, say, hydraulic attribute, and that actually gives us the idea that which might be the vulnerable part of the entire network. And that's why we have come out with another model, risk PINET, we call it, slightly improved version. And the IRWDS was developed by BADEC, Loughborough University, whereas this is our own model. But this gives a fairly good idea about the vulnerable section of this, and then attributes. But it has like so much of say attribute list which we need to collect data on.
Okay.
And, but we can do it as we did in this particular case.
Yeah.
We can easily do it. Yeah.
Just
Yeah, I
last
would.
note.
Yeah.
Excuse me. Can I,
Yeah.
sir? Can I?
Yeah.
Coming to pure engineering area, which one would you consider better? 24/7 water supply or intermittent supply, where I use water in my underground tank and which stays there for 6 months or whatever, I don't know when I clean it. Then it is raised to overhead tank, which is another local storage. And in the process, whatever efforts done at the waterworks by the engineers, heavily compromised. So which one is better?
I think this is very politically sensitive question.
No, I'm talking engineering. I
know.
I
See, what happens is, suppose if we have enough water source, if we have like very intact infrastructure, then I don't mind supplying 24/7. But in case of our country, where where we feel that alternate households, I think, try to get water some one or other way, it is a very difficult proposition. 24/7 is an ideal situation we should get whenever we need. But if you see utilities in places like Surat, Chennai, and Nagpur, we are getting water 24/7 in my house. And we have like sump where we get water from municipality, we pump it to our overhead tank. And whenever we open tank, so see, we have converted our households as a mini utility. So ours is like mini municipal corporation where we are enjoying benefit of 24/7. So why those people who are living in slums, they shouldn't get it? So it has like two sides of the coin, and then it's very difficult to choose between them. But if you see from health benefit point of view, then of course 24/7 is much better. But if you try to make it contextual, then we can say that it's not good. We don't have enough water. One community gets only for 2 hours, whereas others are enjoying. So if you bring the social aspects and economic aspects, then 24/7 takes backseat. So it's not a simple answer. So it depends on the context in which we are talking about.
Thank you, sir. Thank you so much. Nanda sir, would you like to add a word?
Yeah, I think there was one Jani who had raised his hand. I don't know, he's put it down
Just
now.
trying it. Okay.
If he still has a question. I have a question for Dr. Pawan in the meantime. Dr. Pawan, on the E-Jal Shakti server, you have shown that there is a lot of water quality data that is captured, especially the field test kits that are used, and people have been trained to use it. And so today there is a lot of development of these smart field test kits, which directly with, because the existing ones I think are more qualitative. They talk about presence or absence of contaminants, not the ppm per se, because it requires judgment of color and all that. But we have many new company startups which have come up with these technologies where you can put the water drop and maybe a couple of drops of reagent, and there are some without using reagent itself. Can we leverage that to map water quality rapidly? It goes onto the cloud straight away. What are your thoughts on how can we make this a reality, that India has its own water quality map through people participation, which is used by any stakeholder tomorrow? Do you think something can be done on this?
Yeah, see, IMS is, that Department of Agriculture and Sanitation's database. And it's run through states. They keep feeding the data to IMS, and that's how we see it. The two ways I think we can get ourselves engaged into it. One is we, I think, advocate ourselves and then indicate that these are definitely better tools than what has been used, and that can definitely improve water data. I'm sure, depending on the tender processes in each state, if they are satisfied, we can take one district as a pilot and ensure that we
Correct.
collect the data and then prove to them that, okay, this is much better system, and then this improves data by 90% and 80%. Secondly, we can have our own independent system and then run it as a pilot, and then show to them that, okay, we also collected the data from same sources for which the data are already available on IMS, but indicates that, okay, as per us the 60% water samples are contaminated, whereas as per you it's 13%. So there's so much of difference in contamination, so there should be something wrong. We don't question your data, but at the same time, you have to do something so that community gets water. So I think there are multiple ways through which we can really work on it. And let us see that through ministry, through our state government. Ultimately, it boils down to state government. So in case if we can even influence them, then I think we have a chance. We have a chance. I'm not sure whether they'll accept.
We have to demonstrate. You're saying first we have to demonstrate a proof of even with the CSR fund or something, we could attempt it.
Correct.
When the government sees the benefit, then they may bring the policy.
Yes.
But, okay. Sure.
Thank you, sir. Mr. Johnny, do you have any question?
You raised his hand and he dropped
I have one question.
Yeah,
hello,
please.
Pawanji.
Hello.
Hello, Pawanji.
Hello.
My name is Johnny, and we are performing the water quality monitoring using remote sensing. So satellite data, Sentinel-2, Sentinel-3. And right now we are performing more than 75 parameters in hydrological, biological, and phytoplankton. So there are a lot of startups who are claiming that they have better technology, which is cost effective for India, but none of them has a scalable solution that could solve the problem of wastewater treatment. So right now we have identified that we have a problem of nutrient recycling. So if we recycling the nutrient effectively using real-time water quality monitoring, it could save a lot of money in wastewater treatment project, and it can generate a lot of revenue from result-based financing, and it could save the agriculture industry from the nutrient runoff. So what is your feedback or suggestion on this? If we focus on nutrient recycling instead of wastewater treatment?
I think so. If I just want to contextualize it on what I spoke about, IMS at all, they collect data for drinking water sources, most of which are like groundwater. Whereas this remote sensing data will be more applicable to surface water sources like lakes at all. And that's what you precisely are talking about. And I think Central Pollution Control Board collects water quality data not only for, say, rivers, but even for major lakes and water bodies. And they do it by conventional laboratory method. And I suggest that tools which you're talking about, there are many startups which are also coming about using remote sensing data. I think that can be very useful in knowing that what's the level of not only the demand parameters but even for nutrients also. When you talk about nutrient recycling, I feel that I think we have to really work on for what purpose this water is being used or will be used. So suppose it's used for agriculture purposes, then there's no point in say nutrients. We can directly use this water for irrigation purposes. Of course, it should meet some irrigation water quality criteria, but nutrient won't be a problem. So unless we have that sort of understanding, conjunctive use of water, I think it is slightly difficult for convincing policymakers that this data will be useful not only for representation of health of that particular water body, but even for purpose of water use from that source. So my suggestion in this case would be that we have to demonstrate somewhere. Okay, we use this particular tool of remote sensing. We generated this data, and this clearly gave NPK value of this, and we utilize this for irrigation purposes by meeting other water quality criteria, and then we could achieve, say, 30% more growth in agricultural products. Some that sort of study, I think, might convince them. I'm not sure whether it will be convincing to them, but hopefully it should convince them. So I think we should adopt that approach, and the tool you're using is really useful. We don't need to physically go and collect sample, analyze them in laboratory, and then through emergency we do it, and many people are still doing it. So we need to really think, as Mr. Nandakumar also talked about, another tool through which we can monitor water quality. This seems to be another one more additional tool which can also add to our database. Okay, so that's what my take on it is.
Thank you, sir.
Thank you, sir, for your valuable insight.
Yeah. Thanks. Yeah.
So I think with the no other further questions, so I would like to thank you for such insightful thoughts, and I would like to discuss with you regarding this modeling
Oh yeah.
the pipe
Yeah.
connections sometime at your convenient time next week.
Yeah, I'm
Whenever
at
the time
IIT
permits.
Madras
Yeah.
next week. Right.
Yeah. So that's the right
We'll
time
work
to
that out.
we shall discuss that one. Yeah.
Sure.
Yeah. Thank you once again. Thank you all the participants.
Thanks,
Can I
everyone.
have the last interject, sir?
Yeah.
Yeah,
If allowed.
please.
Sir,
Yeah.
MPN count,
Hmm.
MPN count is not a reliable parameter.
Yes.
The scientifically, microbiologically reliable parameter is coprostanol to cholesterol ratio.
Okay.
If it exceeds for more than 0.2, the water is not right. Because E. coli is not a pathogen.
No, it's not.
E. coli is an ideal host for viruses. And there are 700 serotypes of E. coli. So the whole point is that with more knowledge coming in due to advanced technology, some of the engineering textbooks which carry 100-year-old parameters, they need to be upgraded.
Yes, you're very correct.
So
I agree with you. Yeah.
thank you, sir.
Thank you.
Thank you.
Thank you all. Thank you,
Thanks,
sir.
everyone.
Thank you, everyone.